Hi, folks. Welcome back to 3.3, part 4. And so in this last section, we're going to talk about something called the end behavior of polynomial functions, all right? And we're actually going to do this in we're going to look at 4 different types of graphs, right? Rather, 4 different degrees of polynomials. So I'm going to divide this space into 4, right? And in this first piece right here, this first upper quadrant, we're going to look at some ways that we can draw a linear function, okay? So let me go ahead and set up a few XY grids. 1, 2, 3, and 4, all right? And while I'm here, we're going to talk about degree 1, okay? So we know that a linear function has degree of 1, all right? And what I want us to think about is how many turning points it might have. So sort of tagging on with that other one, last section we're talking about, the maximum number of extrema. So we know degree is 1. 1 minus 1 means that there are no extrema for a linear function. And that's true, right? Because we can have a line, maybe something like this, right? We could also have a line something like this, but they never turn. And then maybe some special cases to think about. We could have a line like this, or a line like this, right? But all 4 of these pictures have no turning points, okay? But the question I want us to think about now is how many x-intercepts do we have, all right? And so when we think about x-intercepts, we might notice that this one has 1 right here. This second picture has an x-intercept here. The third picture has no x-intercepts, and then the fourth one has 1 x-intercept, okay? And so when we're thinking about the number of x-intercepts, what happens is that at most, there are, or rather there is, 1 x-intercept for linear, okay? So we can have 1, or we can have none at all. And so that's not a coincidence that we have at most 1 x-intercept and the degree is 1, okay? So I kind of want to highlight these 2 right here. So degree 1, there's at most 1 x-intercept, all right? And now I want to come below this. We're going to draw a few grids again. And what we're going to do this time is we're actually going to look at some degree 3 polynomials, okay? So same thing, let me set up a few grids. Okay. And so in these 4 grids, let's think about what a degree 3 function might look like, okay? And it turns out that a degree 3 could go something like this, okay? How many x-intercepts does that have? Well, 1, 2, and 3, okay? Can I draw a cubic that only crosses the x-axis or touches the x-axis twice? Well, I could maybe if I did something like this. Once, twice, right? And so in this picture, I've drawn a cubic or degree 3 that has 2 x-intercepts, right? Now, can I draw a cubic function that only has 1 x-intercept? Yeah, I could do something like this. Whoops. This. And here I see that we just have one x-intercept, right? Now, could I draw a picture that has no x-intercepts? It's not possible in this case, all right? It's not possible. So not possible to have no x-intercepts, okay? So let's write something similar. Above we said linear, but this one is cubic, which is not degree 1, but degree 3. And if we think about the most number of x-intercepts we have at most, there are 3 x-intercepts, right? So not a coincidence again, degree 3, at most 3 x-intercepts, right? Now, linears and cubics are both degree 1 and 3, which means they both have an odd degree, okay? And I want us to pay attention to the end behavior that's happening here. So in other words, are the graphs going up or down at the ends, all right? Now, since we read in English from left to right, it's important that we read our end behavior from left to right, all right? And so when I look at this line here, all right, I might notice that I have a left end behavior of down, and I have a right end behavior of up. Right? So the way that we would say this end behavior is down up, whatever's happening on the left and whatever's happening on the right. Now, I actually want us to jump over to the cubic one for a moment and notice that in this first picture, I also have down, up, down, up, down, up, all right? And it turns out that if we were to look at a bunch of different patterns, all right, a bunch of different polynomials that had odd degree, so maybe degree 5, degree 7, degree 101, doesn't really matter. But we can tell the end behavior just by the degree and whether the leading coefficient is positive or negative. All right, so up here, we're going to have positive leading coefficient, and down here, we'll have a negative leading coefficient, okay? Now, in these 3 pictures, as well as this 4th picture, it turns out that all 3 of those have positive leading coefficients. So we could say the end behavior for odd degree polynomials with a positive leading coefficient is going to be down, up. Down on the left, up on the right, okay? Now, if we were to make the leading coefficient negative, we'd actually end up with this second picture, where the end behavior is now up, down, instead of down, up. All right, so if I have an odd degree and a negative leading coefficient, it will be up, down. All right, so that's sort of the main story with odd degrees, all right? But we can tell a slightly different story with even degrees. So I'm going to go ahead and draw a few grids again. We'll use these grids to draw some pictures. All right. All right. And so now this time, I don't want to draw a linear or a cubic, but I want to draw a quadratic, right? Which is degree 2. And so I want to draw a quadratic that crosses the x-axis 2 times. And I could do something like this, right? We would have 1 intercept, 2 intercepts. All right, what about drawing a parabola that only has 1 x-intercept? Well, maybe it looks something like this, where this one only has the one x-intercept. And last but not least, can I draw a parabola that doesn't cross the x-axis at all? Turns out I can if I have one that goes like this, right? This one has no x-intercepts, right? And so if we think about what this means, before, if we had degree 1, there was at most 1 x-intercept. If there was degree 3, there was at most 3 x-intercepts. Turns out for a degree 2, there's at most 2 x-intercepts. So at most 2 x-intercepts. Okay. Pretty neat that the degree actually tells us that maximum number of x-intercepts, right? So degree 2, there's at most 2. Now, I don't want to draw all the pictures for these, but I encourage you to do that maybe on your own time. So if we think about the 4th degree, right? 4th degree, sometimes we call that quartic degree, all right? That one, based off of this pattern, how many x-intercepts do you think we would have at most? Well, it turns out there's at most 4 x-intercepts. All right, so 4th degree, there's at most 4. But if we now continue our conversation about end behavior and think about our even degrees, all right, so that would be degrees like 2, 4, 8, 16, whatever it is, we can actually tell about the end behavior again just by knowing whether the leading coefficient is positive or negative, okay? And so let's look at these end behaviors for a moment here. All right, I notice that this parabola, the end behaviors are up, up. And so are these two, up, up, all right? And if I were to draw a picture of a 4th degree polynomial, all right, it might look something like this. And that also has end behavior up, up, all right? So if our even degree polynomial has a positive leading coefficient, it turns out the end behaviors are going to match and they're both going to go up, all right? But if we have something like this middle parabola here that is facing down, this is like a negative x squared, our end behavior is going to be down, down, okay? So this chart, super helpful, but also the information above, super helpful in having us think about like how many x-intercepts can we have, okay? And so now we're going to take a look at a few examples, all right? So 3 examples in particular, and we're going to try and fill in the missing information. All right, so 13, I want a polynomial in factored form that is 3rd degree. So let's see what that might look like. Now, there's a lot of possible answers for this one, okay? But we know if it's 3rd degree, that the maximum number of extrema is 3 minus 1 or 2, meaning I can have at most 2 bumps, all right? Now, the maximum number of x-intercepts, though, that is the same as the degree. So that is going to be 3. So I can have at most 3 x-intercepts, all right? Now, my end behavior, I could choose 2 different ones. I could either have a down, up, or I could have up, down, all right? And so in my polynomial, I'm going to write a blue polynomial that has this end behavior and a pink polynomial that has the other end behavior, okay? Just so we can see more than one example here. All right, so a 3rd degree polynomial that might have leading coefficient that is positive to get this up, down, might look something like this. x squared times x minus 1. That's a cubic. It has 3, 1, 2, 3, third degree. I know it has at most 2 bumps. I know there's at most 3 x-intercepts, all right? And if I wanted to make this match the pink end behavior, right, I could write the same function. I could just stick a negative in front of it. Now that negative right here means that my end behavior will be up, down. All right? So sometimes the hardest thing about these kinds of questions is knowing that there's more than one possible answer. All right? All right, let's take a look at example 14 here. This time we're given a polynomial and we have to figure out all the other information. So I look at this polynomial, I notice that it is in standard form. Everything has already been FOILed out or distributed out for us. We don't need to do that. So that's when we say it's in standard form. And in standard form, we find our degree by looking at the highest power. So this is degree 4. Now we also find the end behavior by looking at the leading coefficient, which in this case is positive 1. So since I have an even degree, my options are up, up, or down, down. But since it is a positive, my end behavior is up, up. All right, let's talk about the maximum number of extrema. That is going to be 4 minus 1, which is 3. And the maximum number of x-intercepts, which is exactly the degree, which is 4. So it might have 4, might have 3, or 2, or 1, or 0, but it can't have 5. All right, last example here. We want to write a polynomial, our choice, whether it's standard or factored form. The only information that we have is that the maximum number of extrema is 8. All right, so if the maximum number of extrema is 8, then 8 plus 1 means I have degree 9. And it means I have at most 9 x-intercepts. All right, now again, I could write something with end behavior down, up, or I could write something with end behavior up, down, all right? And I want to go maybe as simple as possible here. So I could have a 9th degree polynomial. F of x would equal x to the 9th. That would be something that is end behavior matching this, all right? And this one, if I wanted to, I can make it fancier, 2 minus 3x squared plus 1. And if I did that, I would have one that is in standard form, polynomial in standard form. But let's try and be creative, right? Let's try and now have one that has a opposing end behavior, up, down. And let's actually try and write it in factored form too, okay? So one example might be f of x equals negative x squared times x minus 3 to the 5th. Let's see, this is degree 2, degree 5, 2 plus 5 is 7. So I have 2 more zeros I can make. So maybe x plus 1 and x minus 7. Now this is in factored form, and it has degree 9 because 2 plus 5 plus 1 plus 1 is 9. And it has the up-down behavior because the leading coefficient is negative. All right. So my friends, that is the end of 3.3, and I'll see you back here for 3.4.